Algebraic reasoning review 3.1 to 3.3. How could you restrict the domain of the graphs so that the resulting inverse is still a function? Okay, this is domain restrictions. All right, basically is how are we restricting? How are we holding back the x's so that when I take the inverse, which will kind of go like that, but that's not a function. It doesn't pass the vertical line test. So how can I only take a portion of this and make it an inverse? So basically the way to do it is to just break it right there at the vertex. Find a vertex and break it right there. And you either want the right side or the left side. So there are two options. You only got to pick one of them. So if my x value is 0, I either want greater than 0 or I want less than 0. So I can go x is greater than or equal to 0. That's a perfectly legitimate answer. Or an alternative, I go x is less than or equal to 0 if I want the left side. Cool. Same idea for number 18. Actually, pause. See if you can do number 18 already. But if you're not so bold, let's just do it together. So again, we will break it right there at the vertex, and the vertex is at -2. So we either want the right side, which is greater, or we want the left side, which is less than. So we can restrict the domain to x is greater than or equal to -2. Or we can restrict the domain to where x is less than or equal to -2. Okay, and just to kind of show you, if I did the greater than side, if I just did that right side, get a different color. That's what? -2, 3, -2, or 3, -2, -1, 0, -1, so 1, -0, ugh, -1, 0. Okay, so that's the resulting graph. If I only take this right side, if I only take this right side right here, if I only take this side of the line, that's my resulting graph, right? And that is a function. Versus if I only take the left side, I'll get something that looks like, let's pick a different color. I'll get, let's do blue. Go away. Go away. I'll get this side of the graph, which I think goes like that. Okay, so the greater than side will get that one. Okay, the less than side will get that one. That's why we're restricting the domains, and each one of those is a function. All right, and now you don't have to draw these or anything. The only thing that you're required to write is one of those two answers. You don't have to write both of them. So then let's go ahead and delete this so that people don't think. People who are just writing down the answers don't think. So number 19, same idea. Find your domain restriction. So find your vertices. So I got one right here at -2, and I got one right here at 1. So I have three options. I can either be to the left, I can be between, I can either be to the left, I can be between, or I can be the right. So I can say x is greater than or equal to greater than or equal to 1, that's the right side. I can say x is less than or equal to -2. There's your -2, that's the left side. Or I can be in between. So remember, between, you just go -2, less than x, less than, you just put that part in the middle, 1. So that one actually has three options. And so we'll either get the left side, which will kind of go like that. That's a function. We'll get the middle side, which will, come on, erase. The middle side, which will kind of go like that, of sorts, which that's also a function. Or we'll get the left side, which will go like, let's see here, -2, 3, -2, 3, which will go like that, and that's also a function. All right? Erase that. Those are your answers. And you only need one of them. All right. Done.